So you all are welcome to this Vishweshwara Industrial and Technological Museum. You all know today is a very important day for our country. We celebrate today as National Science Day, and you all know why we celebrate this day as National Science Day. And very happy to see that so many students have come over here to witness this program. And today, for addressing you, so we all are very fortunate to have Professor H.C. Verma. He is a renowned physicist and author. When you go for higher studies, if you go to PUC Concept of Physics, he is the author of that book. And so we all are very fortunate to have him here. And today we get the chance to listen to him. And for welcoming you all for this program, I request Srimati Jyoti Mehra, curator of VITM, to give the welcome address.
A very good morning and a warm welcome to all of you once again for this program. My colleague Mr. Biswal just mentioned that all of you know the purpose of this day. As the name states, it's a National Science Day. Can someone please tell us, please raise your hand exactly why do we celebrate this day? Because let's not presume, right? Please. Yes, please.
National Science Day is celebrated to credit the discovery of the Raman effect by Sir C.V. Raman on February 28, 1928.
Wonderful. You have got all the facts in place. Great. Very nice. So this is not a bad thing that you don't know. It's okay. It may happen that we don't know a few things, because there are countless things which are there around, and it's not that with my mind I'll be able to keep everything in place. So that's fine, but that's important is that we get to know as and when we have a chance to know that, right? So such days, why do we, at the museums like this and many other scientific institutes across India and the world, they do celebrate such days. What exactly? Is it only to just remember there was a Raman effect that was being discovered? That also, if we go dig deeper, we need to actually learn that as well. So it's just the fact learning also is not sufficient, but exactly what was it about? So there are a lot of these. So when we celebrate such days, we need to really ponder, why do we celebrate? What is it for us? Especially that when we have the main target audience today being the students. Because this is the right age for you to actually understand how important it is for us to celebrate curiosity, right? To stay, to stay amazed, to stay always at a wondering at the things as to why it is the way it is. Not to go by the facts which are written in the books, right? Because when we celebrate discoveries like Raman effect, exactly how such discoveries do happen, it all starts from the curiosity. Someone like C.V. Raman got curious. Newton got curious. And that when he got curious, he discovered something. It is all that, the discovery, the learning that happens in the process, it is important for us to have the thirst and hunger about as to how and why something is being told to us. So today when we have this session, again, Bishwal has told, and you can all see on the screen that we have Professor H.C. Verma for conducting a demonstration session for us along with a lecture on the properties of light. I'm sure all of you have had the chapter. You have a chapter in your classes. Anyone who has not studied about light, the basics, or you have seen light? We all see light, right? So even we study or we don't study, light has taught us quite a lot. Okay, and yesterday we had a teachers training workshop for us. So we have got certain accumulated knowledge already about it. And we are truly, I'm telling you, before this session starts, there is an amazing experience awaiting you for your curiosity to really nudge on that. So please stay eager. We have a wonderful person today among us, Professor H.C. Verma. Give a big round of applause for his presence. We are truly elated and humbled, sir, for your kind presence, taking a time for such a wonderful and apt occasion to be with us at this Vishveshwaraya Museum. Thank you for your presence and a very warm welcome to you, sir. We have a number of schools that have registered for today's program. I welcome each and every school and along with the teachers that have come here. There are winners of different competitions that we had organized, not only through this week, but there is an annual science quiz program winners that are present here today. So I welcome all the audience that have taken out time on a week and today to be here and to listen to this charismatic talk by Professor H.C. Verma. I would also welcome all my colleagues at this museum that have made all the arrangements possible for this event. Welcome one and all once again. And before we go on for this formal session, it's important whether we all know to a large extent about Padma Shri Dr. H.C. Verma. It's very important for us to give a brief bio about him. I'm just narrating it for a while for everyone's knowledge. Professor H.C. Verma is one of the most distinguished authors of physics in India, often referred as the pedagogical guru for all JEE aspirants. How many of you are really are keen to take up IIT JEE exam? How many? Oh, okay. But it's also good that not everybody raising hand. Really, it's very good. We want to see not only the IITians, not only the engineers, but artists, writers, and teachers. Absolutely, it's so important for us. So so those especially who have raised hand and those who haven't, because it's not only about the facts of IIT JEE, it's about the facts how the nature works. That's what you are going to see today. So please keep alert for the session. So I would continue with the bio once again. He has written several influential books on the physics and is best known for his 2-volume book, The Concepts of Physics. The book is considered as the Bible of physics and is a prerequisite for the students preparing for the IIT JEE or other engineering entrance examinations. Currently, he is the emeritus professor in the Department of Physics at IIT Kanpur. Besides being a prominent author, he is an active socialist who has co-founded many social initiatives like Shiksha Sopan, which means a ladder to education for the growth and upliftment of the underprivileged kids in and around the IIT campus. Sir received his BSc Honours degree in physics in 1975 from Patna Science College and MSc in physics from IIT Kanpur in 1977. Following it, he joined the PhD program at the institute and completed it in less than 3 years. Despite being motivated by his teachers to move to the Europe or US for higher studies, he chose to stay back to his native and joined the Patna Science College as lecturer. This college holds a very special place in the heart of Sir, and that's since it transformed him from an average student who used to struggle with the marks during the school days into a topper. Sir dedicated 8 years of his life to complete the book of Concepts of Physics, which eventually made him a luminary among all students' fraternity. This book has not only shaped the preparations of students attempting the IIT JEE, but it has shaped their thinking. After serving the Patna Science College for over 15 years, he joined the Department of Physics at IIT Kanpur as an assistant professor in 1994. Being a true experimentalist, he did not get convinced by the idea of starting a coaching center, but he decided to pursue research and teach students. His core research interests are in classical and quantum mechanics and nuclear physics also. He has authored another book titled Quantum of Physics. He has also made several video lectures on various topics of physics to help even the Hindi stream students. He is hugely popular among the students and has advised and mentored several PhD students and MSc and also the students of 11th and 12th through his books. So achievements and honors, sir has a number of achievements and honors. We will just name two of them right now. The most, the important one is he is the recipient of Padma Shri by the Government of India in 2021, and he is the fellow of the National Academy of Science, the NASI. So with this very small introduction, guys, I mean it. Okay, so once we invite, yeah. Okay, I would also welcome, sometime, we have another very important person, Mr. Amit Singh, Amit Kumar Bajpayee. He is from the Sopan, Shiksha Sopan Institute, Sansthan, the NGO. So, Amit ji, आपका बहुत-बहुत धन्यवाद यहाँ पर. और आपने जिस तरह से इस पूरे कार्यक्रम को आज इस दिशा में जब हम आए हैं तो आपका बहुत सहयोग है. हम आपका स्वागत करते हैं आज के इस कार्यक्रम में. और मैं अब आग्रह करूंगी बिस्वाल को कि इस कार्यक्रम को आगे बढ़ाएं. Please invite. Thank you.
Thank you, madam, for welcoming the gathering. And now I'd request, Sir Professor H.C. Verma to kindly come to the stage, and because students are eagerly waiting to listen to you.
Yeah.
Thank you, sir.
Yeah. ये कैमरा, ये बीच वाला कैमरा कहीं इधर उधर हो सकता है क्या? I have to reach the last rows also. No. I want to be with them. Closest distance, right? See, any kind of force, if there are two objects, two bodies attracting each other or repelling each other, if the distance is small, the force will be large. Okay? So our interaction will be much more strong if the distance is less. Therefore, I need this passage clear. Happy pity. Okay. All right. This much is okay. I'll squeeze myself and then go. Okay. Good. Okay, so we start our interaction with a very small activity, and I'll request everyone in the front row as well as the rows behind. Okay, no. For some of the students, I'm eclipsed by the camera. It's okay, fine. I'll move. All right. So do this way. Your two hands in the front, then 4 fingers facing each other, and touch them. 4 fingers. Now bring your hand in the line of your eyes, at eyes height, yeah, okay? Now this is the crucial step. Look at the screen, okay? Your fingers should be in between, but you don't have to look at the fingers. You have to focus your eyes on the screen. All right? You will see your fingers because they are in front of your eyes, but you don't try to see here. You try to see there on that screen, and see the finger that you are seeing what kind of shape your finger is taking? Huh? When you focus at the screen, do you see your finger has changed its shape? Don't see the finger. But by default, the finger will be seen. You don't try to see it. So what kind of shape change is there? Yeah? All right? So it is oval type or circle type or sphere type. Oval type, huh? So your finger has changed shape. Now, continue that, and separate the two forefingers just by a millimeter. Just by a millimeter. Why are you laughing? Huh? Why are you laughing? Tell me. Tell me. I am giving the microphone. He is laughing. Tell me.
Disconnected.
It is disconnected.
Yeah.
Yeah. What happened? There is a finger in between the two fingers. Right? And this finger is floating in air. Huh? It's floating in the air. So you have you have created a piece of finger which is oval type in opposite direction and just floating in the air. Very good. Thank you very much. Enjoyed? Good. Very good. All right. So we start our Science Day celebration. Jyoti ma'am asked, why do we celebrate science? And he replied that this is because on that day, 28th February, Sir C.V. Raman did something. Did something. So what that something was? Raman effect. Okay? Raman effect was discovered on that day, right? All right, let me see what I have written yesterday night. Okay. So what had happened on 28th of February 1928? Because discovery of a phenomena doesn't take place overnight. You cannot say that this is the instant when it was discovered. You can say this is the year in which it was discovered, or at best this is the month, because discovering something is a long process. Okay, so why 28th February is celebrated as Science Day? On that particular day, what had happened, that 28th February is celebrated because the research, the findings, and it's not just one finding. Many years he had taken to do a lot of experiments, and each experiment was a success. Some experiment did not work, then he must have modified, and it's a long process. So 28th February, there should be some event on 28th February that we have chosen this particular day as the National Science Day. Okay? This is the day on which he called a press conference. All right? You know what is press conference? Newspapers, you know? And then newspapers are printed in a press. That is why it is press conference. It's not pressing against each other. It's not pressing against each other. Your press is the unit where books are printed or leaflets are printed, newspapers are printed, and these persons who are reporters of newspapers, those people, they are called presswala, press people. Okay, so he called a press conference. All these journalists, all these newspaper persons came, and then he announced that our group is not one person, remember. A discovery is not by one person. There were many people who were working with him, and they all discovered it under the leadership of C.V. Raman. Okay, so he announced that we have discovered a new kind of light phenomena, right? And what is that new kind? So that press announcement of this effect, this new discovery, that had happened on 28th of February, and that is why it is. All right. See, announced a new variety of scattering. Now, you know what is scattering? Scattering? What is scattering? Huh? Is there a cordless mic? Yeah. Huh. No, there's some student has raised hand here. Huh? Who has raised hand? Huh, right. Please give the mic. Huh. So what is scattering? Which class you are in? What is your name?
Eighth. I'm Daksh, and scattering is basically like it's the dispersion of light when it passes through a prism
Okay.
into a band of 7
Okay.
colors known as a spectrum.
Okay, good. Anyone else? You want to add? Huh? What is the scattering? Okay. Okay. What is the scattering? What is scattering?
Scattering is like when light rays on irregular reflection. When a beam of light falls on an irregular surface, and like each beam randomly moves into like different places.
Okay. Okay, good. Scattering. The word is scattering. That means going away from each other. They are all scattered. They have all assembled at one place. Opposite, they have all scattered. So scattered means to get here and there and there and there. Now dispersion is a technical word. It's true. Scattering means dispersing. If the announcement is there, the meeting is over, now disperse. Okay? So that dispersion means now you go your way. You go your house, you go your house, you're dispersed. But in science, or in especially for this light business, dispersion has a very specific meaning. And dispersion is, if you have white light, that white light separates into those rainbow colors. When all these rainbow colors are mixed up, it is white light. And when they are separated, it's all separated, all colors you can see. So that process of a white light showing its own component colors separately, that is known as dispersion. And we very rightly said, Daksh, right? So very rightly said that prism disperses white light into those 7 rainbow colors, right? So that is dispersion. Now scattering is slightly different from that. Okay? Suppose you have just one colored light, red light, right? It has no other components, it's just red light. You can have red lights on the roads, traffic jam, red light. So the light which is coming from that is red. If you pass it through the prism, it will still remain red. Okay? It is one color. Green light, pass through the prism, green will remain green. Yeah? But this red light, when falls on air particles or other water vapor molecules, then this red light, from the bulb it is coming this way, and here is a water molecule, let us say, where it hits that water molecule. Now after hitting, it's not that the light will go in one particular direction. If you throw a ball on the wall, it will go in a particular direction, right? Carom board, if you hit the striker, and the striker hits that boundary of your carom board, and then after that it goes in one particular direction. When this red light from the source, from the bulb, is coming and hitting this water molecule or air molecule, it doesn't only go in one particular direction after that collision, it splits in many light rays of the same color. Huh? That same light which is coming is now broken into smaller pieces. So one piece is going in this direction, red light. Another piece is going in that direction, red light. Another is going in that direction, red light. So that is called scattering. So red light has scattered. It was coming like a beam. Now it is scattered in different directions. One beam has become many beams of lower intensities. Why lower? Because the same beam has been split. So whatever was coming, and now it is divided into all the hundreds of directions. Each one will become weak in intensity. So that is called scattering. Okay? But it's not that all the light which comes will be scattered by this water molecule. You will have light which meets the water molecule, says hello, hi. All right, this light is coming, it is meeting this water molecule, and the two do exchange greetings, and the light goes in its own way. It doesn't scatter. It meets that molecule, but okay, it goes forward. Right? So when the light is coming, a fraction of it gets scattered, and the remaining goes straight. How much fraction will be scattered? What percentage? 10% will scatter, 90 will go ahead, or 20% will scatter, and rest will go ahead. That depends on the color of the light. Okay? The red light, the percentage of scattering is less. Green light, it is more. Blue light is even more. Larger percentage will be scattered. So the scattering, how much light will get scattered, depends on the color. Now tell me, the same sky, you see in the morning, or at the same time also. One side of sky is reddish, morning time. Other side of sky is not reddish. It's bluish. You all have, you know that? You don't have to read in the textbooks. You all see the sky. In the morning, you turn towards east, and you see that, okay, the sun is rising, and that eastern sky is red. Sun itself is red, but the sky is also red. The whole sky is red in that direction. But if you turn some other direction, you find only the blue. Right? You turn towards, say, south or north or west, or you look overhead. You don't find red there. It's the same sky. In the evening, it becomes opposite. So it's not the sky which has changed. What has changed? Color. And why? Why color has changed? Because of scattering. And different amount of scattering of different colors. Red is scattered least, and blue is scattered most. And in between is that Vibgyor. Right? From red to blue and violet. So that sequence is there. In that sequence, that scattered intensity proportion will change. So if light is coming from the sun directly, it's white light. Sun always emits white light. Is it okay? Why? In the morning, it should. I see that in the morning it emits red light. We see red. Sun is red, and in the noon time, it's white. Okay, so each sun emit red light in the morning because I see it is red, and white light in the noon time or 10 o'clock or 11 o'clock because it becomes white. Is it that? No, the sun does not know your 10 a.m. or 6 a.m. or 5 p.m. the sun keeps shining in the same way, right? It's your earth which is going, which is rotating. You have made morning, this is the morning time, this is the evening time because of the earth's rotation. Sun is always emitting which color? White color. But when the light comes from the sun or around to us, the red color is what? Least scattered or most scattered? Least scattered. That means lot of red will come into my eye. And the blue has scattered this side, that side, that side, that side. Green has scattered this side, that side. So the light which is entering our eyes seems to be red because the green, blue, violet, they have scattered out in the path. How long is the path? From the sun to me. From sun to me, sun emits light, I receive light. Huh? How much is the distance? Lot of distance. Huh? Lot of distance. You know 10,000. You know 1,000? Right? 1,000. Then 10,000. Then 20,000. Many of us have salary of rupees 20,000 per month. So we know how much is 1,000. 10,000. And 10 times 10,000 is 10 times 10,000. 100,000 is 1 lakh. And 100 lakhs is 1 crore. And the sun is at a distance of about 15 crores. Right? ठीक बोला ना? Okay? But does the scattering takes place all those 15 crore path length? Why not? Why not? Oh, there are no particles. Oh, it's all vacuum. The particles start meeting light, or light start meeting the particles only where it hits our atmosphere. And our atmosphere is only how much? How much distant is our atmosphere? Some 300 kilometers. And most of it is 20 kilometers. Most of the air is in 20 kilometers only. And after that, the air becomes thinner and thinner and thinner and thinner. And 100 kilometers is almost nothing. But then this 20 kilometers or this 100 kilometers, where air is there, scattering starts. And therefore, we receive only red, rich red component and small amount of others. It is red. But if the sun is on that side, which is east direction in this hall? Okay, okay, fine. So this is east direction. So in the morning I'm standing like this, and I see the light which is coming to my eye is red. Now I turn 180 degrees. Do I still I'm receiving light, or it's all dark? I'm receiving light. There's nothing to study about, nothing to explain about. In the morning when you wake up, sun may be somewhere, but in any direction you change your orientation, any direction, you see, okay, you are seeing things. Oh, you are seeing all the kind of trees and buildings and everything, roads, cars, everything. So light is still coming in your eyes. Okay, the sun is here and I am here, and light is coming in my eyes. How come? The sun is on that side. How do I receive the light from this side? Scattering. The light is coming from the sun, meeting those particles, nitrogen particles, the nitrogen molecules, oxygen molecules, water vapor molecules, carbon dioxide molecules, getting scattered in all directions. And some of that is coming also in my direction. So I see that. So I am seeing only the scattered light, not the direct light. Okay? Now which color is scattering most? Violet. So I should get lot of violet from that side, because I am receiving the scattered light. But I don't see the violet. Do I see the violet? Huh? Scattered?
It scatters so much over such a large area.
Okay, very good. But yes, very good. She is saying that since it has scattered in the way, and therefore the remaining doesn't have any more violet. Okay? Well, yeah, that's also a good logic. But the thing is, in the white light, when we say that we have red, we have blue, we have green, we have yellow and violet, they are not all in the same proportion. It's not a homogeneous mixture of colors. And violet is the least in that proportion, which makes it white light. The violet itself is a very small proportion in the white light itself. Now, on the other side you have red, but that also, that red is very wide because there are varieties of red, correct? The red shirt that he is wearing, the red coat or shirt, what it is, your jacket, so that red, then madam is here with red sari. All these reds are different from each other, isn't it? So even if the extreme red is very rare, like extreme violet is very rare, but you still see a lot of red, because the red sensation is not only from a narrow range, but it is wider. There are varieties of red. Okay. So since I am finding only the scattered light, and scattered light has blue end at the most. Blue has a good proportion, and our eyes sensitivity is also important. It is very small for violet and more for green and so on. So that is why I see the sky blue here, and I see the sky red here in the east. All right? Okay? So this is called scattering. Now C.V. Raman, during his laboratory work, he found that when light, a particular light, color, a particular colored light is sent on a liquid, and it passes through that liquid, the liquid particles also scatter light, just like scattering. But among that scattered light, a very small fraction, very small, 1 part in 10 to the power 6. 10 to the power 6 is 10 lakhs. So out of 10 lakhs, only 1 part, that small amount of that scattered light has a very, very different character. Very, very different. What different character? C.V. Raman did his experiments with violet light. Okay? Pure violet light. Pure violet light. No green, no yellow, no red. Using filters, he got pure violet light, and this pure violet light, if it is scattered from molecules, it goes in different directions. So what will be the color of those scattered light? Violet. It's all violet. Only that violet is splitting here and here and here, going here. And it did show this behavior in Raman's experiments also. But Raman's experiment, his instruments, could recognize that one small part of that scattered light is also green. There is no green coming. There is no green coming. And when it scatters, it goes through that liquid, and as long as it is in the liquid, it is scattering, and that scattered light is being analyzed by the instruments. He finds that yes, it is violet, 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 all the time, violet, violet, violet. But a very, very tiny fraction. How tiny? 1 part in 10 lakhs. 1 part in 10 lakhs only. Green. So this is something fantastic. The liquid particles have changed a tiny part of this light from violet to green. So this is a very different kind of scattering. Normal scattering, this color will not change. But in this experiment, they found that yes, without change of color, you have a lot of scattering there. But then he could manage to see that so tiny fraction, 1 part in 10 to the power 6, has changed color. Okay? So this was a totally different phenomena, and that is called Raman scattering. That part is called Raman scattering, where it is changing the color. And how much will be the change in color? Huh? 1 part in 10 lakh, right? But not always it will be from violet to green. Sometimes it may be violet to something else, not necessarily green. And it will still, to the eye, it will look a screen. But I said, all reds are not the same. Similarly, all greens are also not the same. Okay? So sometimes it will give me this green, somewhat slightly different green. Eyes will not detect, but the instruments will detect. Instrument will say, no, okay, that green is different, that green is different. Okay? Now, which green? In scientific terminology, every color is given a number. In your class, your name may be something, but you are given a roll number. And you are identified by that number. Roll number 37. Yes, sir. Correct? So each color is given a number. And that number can vary from, let's say, 400 to 700. All colors are numbered as, this is 400, this is 401, this is 402, this is 403. They will all look same into the eye. But the instruments will tell, okay, this is 400, this is 401, this is 402, this is 577, this is 578, this is 580. So each color is given a number, and each color is different from the other color. If the number has changed, that means, okay, the color has changed. To the eye, it will not appear as different, but to the instruments, yes. So they found that change in color, that means change in that number which recognizes that particular, depends on which liquid we put there. If you put water, if you put acetone, if you put some oil or some, so what liquid you have put there, that decides which color will be that tiny part 1 in 10 lakhs. Which, whether it will be, I am sending a light of, let us say, 530, and the roll number is 530. They call it nanometers. So 530 nanometers. Then whether the scattered one will be 536 or 537 or 542. So that shift in the color depends on the liquid. And since the scattering is taking place from the molecules, so since different liquids will have different kinds of molecules, therefore different liquids will be shifted in that Raman part of the scattering by a different amount. So I cannot see the molecule. I cannot see the molecule. Even microscopes cannot see the molecule. But the instruments can see that change in color. So by that seeing that change in color, I can get information about the molecule without seeing it. What I am seeing is the change in the color as it scatters from that liquid. But the scattering has taken place because of the interaction of that light by the molecules. So different kinds of molecules will interact in different manner. So if I measure that shift in the color, I am getting the information about the molecule. So this was such a strong tool to study the molecules in a liquid without actually seeing them. How do they vibrate? What kind of structure is there? How many atoms, that bond length, how much is the bond length? The atom to atom distance is how much? So many of the properties of the light of this liquid could be studied by studying this, that tiny part of Raman scattered light, right? So that is what this Raman effect is. Okay? Good? Good. All right. So let's go ahead. Now what science, this is a National Science Day. It's not National Raman Day. All right? It's not National Raman Day. On this 28th of February every year, if we remember C.V. Raman, we talk about light and other things, but basically it is a science day. So what science can do? This is a question. And you know, X-rays, the Ranjan, German physicist, discovered X-rays. That is science. That's the victory of science or triumph of science. And you know, when you play in the ground and then someone pulls your leg and your bones get distorted or broken, how do the doctors make you fit? They cannot see the bones, where it is broken, all right, and how much it is broken. So they do the X-ray. So Ranjan, who was a scientist, who was an experimentalist, and scientists also have only two eyes, like all of us, only two hands. Scientist is not something divine creature. They are not divine creature. They are just like us. But as Jyoti ma'am saying, scientists are curious. They are curious to know what is happening, how it is, and why it is happening. And if it is happening this way, the rule of nature is this, then what kind of things it can impact on us. Scientists will be very curious and look for those answers. That's it. Otherwise, they are no different from us. So Ranjan discovered X-rays, and that X-rays worldwide, it is impacting our lives. Correct? Next. Who is she? Marie Curie. She discovered radioactivity. And you know, all the cancer patients are given that's radiation therapy. Right, all kinds of, there's so many uses of radioactivity. Cancer patient is only one. It has impacted the world in a great way. Science always impacts the world in very great way. It has the potential of doing that. Okay, Jagdish Chandra Bose displayed wireless communication using millimeter range radio waves. Technical term, millimeter. This is also a kind of color which we do not see anything from the eye. The things we see, the colors of light or light that we see with our eyes will go from 400 nanometer to 700 nanometer, I told you. Now this is millimeter, and 1 millimeter is 10 lakh nanometers. So this is light of roll number. How much? 10 lakhs nanometers. 1 millimeter is 1000 micrometer, and then 1000 into 1000, 10 lakh. 10 lakh nanometers. Our eyes can only see from 400 to 700, but it is still light. It is still light. We name it differently. We call it, the general name is electromagnetic wave. Okay, our light is also inside that electromagnetic waves. They have same character, except that color, 400 or 405 or 530 or 670 or 700 or 1000 or 10,000 or 1 lakh or 10 lakhs. On this side, it may be 400 nanometer, 200 nanometer, 100 nanometer, 10 nanometer, 1 nanometer, 1 by 10 nanometer, but these all are all colors of eyes. What we see with color of light, what we see with our eyes is a narrow range of light. There's nothing this side, that side. Jagdish Chandra Bose used that millimeter, that means 1 lakh of that order, 1 lakh, 2 lakh nanometer light, which we call EM wave, to use this wireless communication. Okay? And the whole world is now connected by Wi-Fi, you know that. And that 5G technology, you have heard these words? 4G, 5G, 3G. Earlier it was 3G, 2G. Now it is 5G. It's very common. Now people are working for 6G. This 5G technology is basically based on this radiation, this kind of light. Good? So now the science, impact of science. Satyendrath Bose formulated theory of this electromagnetic wave, which also we call radiation. All right? And that theory, that understanding, the mankind understood the true quantum nature of radiation because there was a person, Satyendrath Bose, who worked hard. He did not do experiments, but he could manage to understand what this radiation is and constructed a very nice theory together with Einstein. And that theory is now known as worldwide Bose-Einstein statistics. Okay? Bose-Einstein statistics. Satyendrath Bose. Whole class of particles are known as bosons. All the particles which are in the universe, they are divided in two parts. One part is called bosons. And why bosons? Because Satyendrath Bose described the theory of it. He developed the theory of it. That is why the whole bunch of particles are called bosons. And the rest of the particles are called fermions. And that is because, like Satyendrath Bose, there was another science person, another physics person, the Enrico Fermi. He developed theory for the rest of the particle. Satyendrath Bose developed theory for all these particles which are called bosons. And the rest of the particles, this Enrico Fermi, another physicist, another science person, another scientist. And those whole particle is fermions. And that's it. A particle is either boson or fermion. That's it. So what a wonderful work this scientists are doing and science is doing. Okay? J.J. Thomson, that you... Thomson's model of atom. And you also know that there are limitations or failure of Thomson models. Do you study in textbooks? Why Thomson model is wrong? Nothing is wrong. Nothing is wrong. Thomson discovered electron. Through his experiments, we came to know that the atom is not a thing which cannot be broken. Atoms also has parts. Atom also has parts. The electrons exist, negative charges exist in the atom. So Thomson experiments with that discharge tube. You have a model on the third floor. Electronics gallery, you have a this Thomson is sitting with the operators. You can all see that. Oh, it's never wrong. Experiments are never wrong. Experiments are never wrong. Experiments are experiments. We do not do the experiment. Scientists do not do the experiments. Scientists only assemble the experiment. They think of that, okay, this type of assembly, this type of experiment will reveal this information. So they design the experiment. They assemble the experiment. But they do not have any authority to perform the experiment. Nature performs the experiment. You do not. How many of you have done the simple pendulum experiments? Simple pendulum experiments? Good. So what you have done? You have taken a thread, very good. You have put the bob, very good. And then you have pulled the ball in one side and then left it. You have no control. You have no control whether the time period will be 2 seconds or 1 second or 3 seconds or 4 seconds. Who decides what is the time period? Nature decides. The laws of nature decides. If this is the length of the pendulum, this will be the time period. We only make arrangements for nature to tell us. Nature to tell us that, okay, this is the rule. It follows this particular rule. You do the experiments, and then the nature tells you, okay, for different lengths you measure the time period, and then you say, okay, nature has whispered that the time period is proportional to square root of length. You have no control on that. You don't have any control on that. Experiments are never wrong. because the experiments are actually dictated not by J.J. Thomson or anyone else, it is dictated by nature. But the beauty is a scientist, a curious scientist, a hardworking scientist, a passionate scientist can think, if I design this kind of experiment, I can get a new information from the nature. All right? So, and discovery of electron is the basis of all kinds of chemistry. Huh? All kinds of atoms joining, making molecules, then molecules joining ionic compounds, crystal lattice, this, that. So J.J. Thomson has a great contribution in all the chemistry, all the physics that we know, and so many products we are all using based on that. So that's the kind of science. All right. So what is common in all this? I have just collected some 4 or 5 names. So what is common in that? In all these people, J.J. Thomson, Jagdish Chandra Bose, Satyendra Bose, Fermi, they were all students like you. Each one of them at this age that you are sitting here, they were all students of some schools. They were not extraordinary persons. They had the passion, no matter what will happen, I will do science. They did not think, if I do science, what will be my salary? If I don't do science, I do my business, how much I will earn? They were for learning, not for earning. Okay? That's the difference. They were as ordinary students as you all are. Fine? Okay? So that's the commonality. So any one of you sitting here in this hall can do big impacts on the society. And remember, I am giving you the names. No, what is not needed? Remember, any of these great names that I have said have not done that alone. Okay? Lot many people have done some work. Some information is there, some information there. To J.J. Thomson, there are a lot of information which the previous scientists had collected. And all have contributions in the discovery of electron. J.J. Thomson is given that credit because finally, the final experiment which showed the existence was there. But did J.J. Thomson designed what will be a discharge tube? No. Huh? So even if I am not as famous as J.J. Thomson, if I have done some science experiments and came out with something new, it not be as impactful as electron discovery or Rutherford's experiment on nucleus, but it all contributes. About this all accumulates, and finally the final blow is there to make that discovery. So any one of us can be in that team which will be impacting the society, the world, the universe, either in my lifetime or beyond my lifetime. Right? All right. They all impacted the world in a very positive way. Would you like to be one of the game changers in solving world problems? Yes? Yes. That is important. Oh, the salary, the package, the job security. They never thought of any job security. If I get a government job, I will be safe. If I have a private job, then the owner can fire me. No such thoughts. No such thoughts. What will happen to me, my family? And I tell you, the one who can think originally, the one who can, for whom questions appear, and the one who can try to find the solutions, not by reading the books, not by asking ChatGPT, but thinking, that person will never be beyond the basic necessities. Whatever the basic necessity is there for survival, so that much every person will earn. And if you have this ability, you will earn much more than the average. But don't compare that particular the industrialist in the wedding ceremony, all those crore rupees of saris and crore rupees of this. In my family, it was not that. Don't compare with those things. Don't compare with anyone. No one will be happier than you if you do science. No one will be happier than you if you do something to contribute towards the society. All right? Okay. Okay. Now, the world problems I was talking is to solve world problems. Many of these scientists are very instrumental, or the science is very instrumental in solving the problems, the world problems. Right? It can be in medicine, vaccine, for example. Right? Vaccine, the polio, there's no more polio in India. So the people who invented all these vaccines. So any person who is contributing towards the society will always be on it. Okay? Now one such problem world is facing is this imbalance or disbalance of environment. And that is affecting the whole life on the earth. One problem in general, one problem is problem of a certain part of the world, right? But this problem is problem for the entire life cycle on this universe, and therefore we should all know about it, right? So a few slides on that. You know, Earth is the only known place in the universe to have life, correct? Nowhere else there is any life, at least we have not known, and we are very powerful people. We have a lot of technology with us. We have a lot of science with us. We have predicted that the universe started, so how much? 13 billion years ago. So we have that power. Sitting here, I can tell what had happened. 13 billion. Billion is that 100 crores is 1 billion. 14 billions ago, this had happened, Big Bang. From there, universe has been generated. I am telling, sitting on this earth. We are such powerful people. And we have not found the life anywhere else. Huh? We can safely assume, of course, finally we may be wrong, but we can safely assume that, or can tell, till it is contradicted, that life exists only on this small planet which we call Earth. This is the only place to have liquid water, which is necessary for survival of everything. The mountain feeds us with fresh water. Snow in glaciers reflect sunlight. This reflecting sunlight is very important. And why it is very important? Atmosphere gives us oxygen to breathe, nitrogen to give nutrition to plants, and little carbon dioxide. How much is carbon dioxide in the air? Good. You all know that. This is very tiny, very tiny. Water is much more than that. Water vapor is much more than that. Okay? But this carbon dioxide impacts our earth in a very major way. And therefore we talk of carbon dioxide. You must have heard the global warming and carbon emission and carbon source. People are talking that. I will be talking on that. So that tiny amount, 0.04% of carbon dioxide, that keeps us warm. Soil gives us agriculture. So earth is the place where the life flourishes. All right? So there is a big ecosystem. Plants, they prepare food for us. Perfect distance from the sun, moderate temperature. If we are slightly closer, the temperature will be high. Slightly further away from the sun, it will be very cold. And plus 120 degrees Celsius during day and minus 130 degrees Celsius during night. Which place is this? Moon. At moon we don't have atmosphere. At moon we don't have carbon dioxide. Okay? So see what happens to moon. Moon and Earth are almost same distance from the Sun. Sun is 15 crore kilometers away from that. Moon is only some 1.5 lakhs or how many? It takes 1.1 second for light to reach, right? So 300. Okay, so it is still in thousands or tens of thousands, and that is 15 crore. So Sun and Moon are at the same distance from this. Earth and Moon are at the same distance from the Sun. Earth has so comfortable temperature, day and night. Day and night variation is hardly 10-15 degrees Celsius, and at Moon this is the variation, at the same distance from the Sun. So our atmosphere, our carbon dioxide, our nitrogen, our oxygen is very, very important. That balance is very, very important. Then Earth has Earth behaves like a magnet. You know that? You know that? If you take a bar magnet and hang it, it always goes in north-south direction. Why? Because Earth itself is a magnet. The Earth's south pole attracts this north pole of that hanging magnet, and the other side will attract the other one, and it will finally go there. Now this Earth's magnetic field is extremely important for us. It's not for compass and the bar magnet. It's much more than that. From the Sun, not only light comes, but particles come. Okay? Particles come. Charged particles, like protons, they also are ejected from the Sun, and they are coming towards us and everywhere, in all directions. Sun does not know which direction is Earth. So he is not firing on the Earth, and it is not avoiding the Earth. People are living there, we should not go that way. They are coming with great speeds to hit the Earth. It is this magnetic field of the Earth which is deflecting them away, and they are not able to hit our Earth. All right? So everything is so nicely interlinked that we live so comfortably on the Earth. And any kind of disbalance in that will be very, very crucial, and the whole life system can be in danger. And that is happening. Nature is in a delicate balance. It's a delicate balance. If I just go for the temperature, okay, and this balance is in danger because of this. Humans. No one else is doing that. Sparrows are not doing that. Snakes are not doing that. Whales are not doing that. Plants and trees are not doing that. Cats and rats are not doing that. But this egoist person, I have all the wealth in the world, and I can do whatever I like. All right? So this species, this most intelligent species, is the biggest danger for the life on the Earth. So this is the temperature balance. From the Sun we are getting light, okay? And then this light is coming on our planet. They warm it during the day. But not all the light is reaching all the light which is directed towards Earth is not able to reach the Earth, because in bit there is atmosphere. So a lot of light is reflected back by the atmosphere, and only small part we are getting here. Okay? And during night times, we radiate. The Earth radiates. During daytime, it has to receive that sun, and it becomes warm. Now then the sun is gone, it's night time, then it will give off the light because it is warmer. You know, warmer things will give heat to the surrounding. Warmer things will give heat to the surrounding. If you put a hot water in some kettle or something, after some time it cools down. Where has that heat gone? Yes, right. Similarly, if the Earth has become warmer in the night, it will radiate, it will give off that heat to the atmosphere. But that heat should go out. But the carbon dioxide sitting in the atmosphere says, no, don't go. So be here. So this is a very delicate balance. 0.04% is a very crucial number. It sends the right amount of heat to allow to go out, and the right amount of heat to reflect back to the earth, to retain there. If it is not retained, minus 130 degree. Remember. So that 0.04% of carbon dioxide, very important, should not get reduced from there and should not exceed that. Should not exceed that. If you exceed that, it will be trapping more and more heat. And if it is trapping more and more heat, the average temperature of the earth will increase. If that increases, the whole delicate balance will be in danger. The snow will melt in the glaciers, and that water will flow in the seas. The level of sea will go up, and the level of sea goes up by even say a few centimeters. You know how much of area will be flooded and will be lost. So many things will happen if the carbon dioxide is increased. But the balance is, okay, let me first tell you how the carbon dioxide can be increased. You know that? Burning of petrol, diesel, CNG, PNG, whatever, produces carbon dioxide. All this fuel which we use to cook food, to run our engines, machines, all these fuels, when they are burned, they produce carbon dioxide. They increase the carbon dioxide in the atmosphere. Fine. But then, and similarly, you have this electricity generation. The generation of electricity is also done by how is electricity generated in thermal power plant? Burning of coal. So much of electricity we are using. So much of electricity is being produced because we need that. And so much of coal we are burning every day. And so much of carbon dioxide we are adding to the atmosphere. Okay? Burning LPG, that also adds. And then breathing out. Everyone in this hall, including me, including director sir, everyone is adding carbon dioxide to the atmosphere with every breath. Which gas we take in? Oxygen. And which gas we give out? Carbon dioxide. So, and which we breathe in using our nose, right? And our nose is immersed into air. From that air only we have to breathe. So in that nose, is there some kind of a gatekeeper? When air comes, air has 78% of, and 21% of, and 0.04% of. So the gatekeeper identifies, you don't have your Aadhaar card is not there, you are not allowed to go in. You are nitrogen? No. You are oxygen? Yes. You are carbon dioxide? No. Because I have to breathe in only oxygen. Is there something here? Is there something here which can identify which atom, which molecule is nitrogen and which molecule is carbon dioxide and which molecule is oxygen? No, it's not there. We breathe the whole air. All the 78%, all the 21%, all the 0.04%, all the air, this moisture, everything, what is there in air, the air goes in. And it's not that carbon dioxide comes out. The nitrogen which is going in, if that doesn't come out, and every breath we are putting more nitrogen, more nitrogen, more nitrogen. And we do not throw away that nitrogen back. What will be our size after 1 hour? We breathe out all the 78% nitrogen. Okay? And all the oxygen, not all the oxygen, we breathe out 17% of the oxygen. We take in 21% and then we breathe out 17%, the rest 4%, what happens to that? Yes, that goes for our own cell functioning. Goes in blood and attached to hemoglobin and this and that. So that 4% is used up there. And when that is used, carbon dioxide is produced inside our body. Okay? During the digestion process, carbon dioxide is produced in the body, and that increased carbon dioxide, which is about 4%, because 4% oxygen is consumed, so the same percentage of carbon dioxide is produced. So what we are breathing out is not carbon dioxide, it is 78% nitrogen, 17% oxygen. 21 we took, 4% we used, 71% oxygen we are breathing out. And this extra 4% of carbon dioxide that we have created in our body, that is also, so we take less carbon dioxide, 0.04%, and we breathe out more carbon dioxide, 4%, right? So that's the breathing pattern. But we are adding to carbon dioxide. All the time we are adding to carbon dioxide. We take 0.04% in, and then we give off 4% also. With every breathe we are adding that. All right, good, very good. But it's a balance, it's a delicate balance. If there are sources of this carbon emission, right, we are all emitting that carbon in the form of carbon dioxide, there are also sinks for carbon. We absorb carbon, and I am one of them. I am 77 kg, all right? I am 77 kg, and I am 15 kg of that 77 kg is carbon, and I have stored them. No, this cannot go out. I have stored them. When I was born, I was hardly 2 kg or 3 kg. So only a small amount of carbon was there. When I am growing up, you are all growing up. Okay, your weight is increasing, your mass is increasing. So you are trapping carbon dioxide. Oh, you are trapping carbon. Don't go out, remain here. You are not allowed to become carbon dioxide and pollute my atmosphere. Each of us, all the trees, basically carbon, carbon, carbon. All the trunks, even after the trees are dead and furnitures are made, this table is made from the tree. The carbon is still trapped here, okay? Is still trapped here. So there are carbon sources from which carbon dioxide is going into the atmosphere, and there are in the nature there is mechanism. There is mechanism where carbon dioxide is absorbed. It's not allowed to go into the atmosphere. So that is how that delicate balance is maintained. But then if too much of carbon dioxide is produced, this natural cycle will not be able to maintain that balance. If too much of carbon dioxide is produced, then this mechanism of trapping carbon will lag behind, and then we will be in danger. Okay? So we cannot stop breathing out. Should we? No, not at all. We have to breathe in, we have to breathe out. We have to add carbon dioxide. Good. LPG we have to use. We have to cook food. We are not those animals who are grazing grass and leaves and then supporting their life. We have to cook our food. So that's all the necessary things can be handled by earth itself by absorbing right amount of carbon. You give carbon and the earth will absorb and the balance will be maintained. But if too much of unnecessary carbon dioxide, these are unnecessary carbon dioxide emission, breathing and LPG and little amount of electricity. But it is, if you produce unnecessary, you have a habit of producing unnecessary carbon emission. There is no one in the room, but still the lights are on. Lights are on means you are using electricity. and you are using electricity, that means the coal was burnt for that. So this is unnecessary adding of carbon dioxide. That should be avoided. That should be avoided. No extra lights, no extra fans, no extra ACs. In fact, AC should not be used anywhere. Huh? Okay? So you have to curtail everything. Everything, because the industries are growing, factories are growing, lots of machines are running. Anything that you purchase. Okay, let's see this one. This is a picture of lift. So in one of the programs, I had to go to earth floor. So I was in the ground floor, and when the lift opened, I entered into it. And somehow I had my phone camera on. So this lady, oh, if you are only seeing the hand, but with the hand, can you estimate age group? Not an old person, right? 20s, maybe 20s, yeah, you are right. So not an old person, not disabled, very good health, maintaining health, young. Now she came and pressed which button? Oh, from ground she is entering and pressing one. And remember, if I were not there, the lift was perhaps somewhere 4th, 5th floor. When I pressed the button, it came down. If I were not there, she would have pressed that button outside that lift. And the lift will come from 5th floor, or maybe 8th floor or so, or maybe 20th floor or so. The building was some 20 floor high. The empty lift will come from there. And then this lady will go in, press one, will come out. How much electricity is wasted? Huh? If a disabled person on wheelchair, yes, going to first floor using the lift is okay. But what is this nonsense? So this kind of extra CO2 emission has to be checked. But these are only temporary reliefs, you can say. Science has to come in. Technology has to come in to get the solutions of this ever-increasing carbon dioxide content in atmosphere. Okay? Brand menswear. Oh, okay, starting from rupees 200 only. So oh, it's so cheap. Let's buy 5 of them or 10 of them. It's so cheap, 200. When else we will get this cheap T-shirts? If you don't need it, don't buy it. Because this T-shirt was prepared in some factory. Lot of machines were used there. Lot of electricity was used there. Then this shopping mall or shopping center is not next to the factory. These garments are prepared maybe some 100 Ludhiana. From Ludhiana they come to different places. So transport is involved. Transports means again burning diesel or petrol or something. So that much of carbon dioxide has gone into the atmosphere, right? Then when it comes to your shopping mall, the shopping mall has to be chakachak. Lot of electricity will be used there. Huh? The packing material. You purchase, I'm sure you are not giving me any gift. Normally, when you gift to someone else, you wrap it in a very bright kind of plastic sheets, right? And put red thread here and there and there. The gift you are giving is good. So I will use that gift. Maybe I will place it in my office. It is a calendar or something else, or it's this coffee cup. I will be using it. But the wrapping on that chim thing, I have to throw it out. I have to turn it, and sometimes people say that yes, you turn it here itself so that audience also came to know what gift was given. We are not So that 10 seconds of life. Good, good, very good, thank you. That's the spirit of Science Museum. For that 10 seconds of use, it is brought to you and is given to you. Photographs are taken, and then you turn and throw it there. That also was manufactured in some factory. That also was transported to the shop. That also had a lot of carbon footprint. So the first measure everyone should take, everyone, is to avoid all these things. Don't throw anything. Don't throw anything. Use it again and again and again and again.
280 liter water.
Oh, yeah. Right. Correct. But that doesn't mean that we'll stop eating idli. Okay. All right. So this is the one everyone has to do, right? And then scientists have to design solutions, long-term solutions, how to save our Earth. Okay. So everyone should participate in the whatever capacity, but you should plan down the line, 10 years from now, 5 years from now, 15 years from now, 7 years from now, you will be designing more impactful solutions and to save the Earth. Okay? Very good. All right. So thank you very much for listening. And the final word is life must be useful. Life must be useful. That's the meaning of success of life. Okay? Thank you.
Conscious living as well.
A few questions can we take?
Okay. Okay.
It will be hard to conscious.
So really, it was a mesmerizing lecture by Professor S.C. Verma. He has given so many tips how to reduce carbon dioxide. Actually, you are the people who are going to use the next Earth. Okay, so you have to keep our Earth safe for your use next. So, many times we have seen also young kids also use the lift of a museum from 0 to first floor itself. So in whatever possible way you can do small things that will add on to reduce carbon dioxide to our atmosphere. And Sir has very nicely explained about the scattering of light and Sir C.V. Raman's effect and all this about the particles of bosons and fermions. Definitely students have got benefited for this. And I would request Sir, if you are having in questions, hardly only 3 questions only will take. If anybody interested, please raise the hand. Then only 3 questions will take. Only 3 questions.
Yes, sir.
Everyone should listen to this.
Here the first boy. Here this boy, first question. Yeah, Mike. Yeah, then second question will be that boy. Yeah.
What if different colors of light are used instead of violet?
I didn't get your question.
Instead of violet rays of light, what if different colors of light are used?
In Raman's experiment.
In Raman, okay. Well, that depends on what liquid you are trying to study. So nowadays it is laser. At the time of Raman, it was not laser, so various kind of filters were used. But now you have tunable lasers, and you can always use light of any color. Okay, that any roll number between 400 and 700. But normally it will be at the blue end or red end. The blue end or green end or the violet end. Because the the Raman scattered light which comes, that has a larger number or lesser energy than this. So depending on this which liquid you are studying, molecular structure of which liquid you are studying, you choose your initial color. But it will be violet or it will be green. Mostly nowadays people are using green, but there may be some liquids for which maybe blue is more useful. So they decide depending on what experiment. But it's not at the red end. It will be on the violet end.
Sir, so what are the applications of the Raman effect? Raman scattering.
Yeah, the basic application was to study all these molecular structures and how molecules are vibrating within themselves. A molecule means there are several atoms, right? A molecule means there are several atoms which are attracting each other, they are not flying off. So if they are attracting each other, they will not stand still, they will oscillate, and there can be varieties of oscillations. And those will decide the impact of this liquid, what this liquid will do if I mix it with this thing or that thing. So basically the Raman scattering is used for knowing the molecular structure, and not only the structure which atom is where, but the frequencies or the time periods of varieties of oscillations which are taking place inside that molecule. And then their applications. When Raman effect was announced in 1928, in the just next 2 years, as if the whole world was waiting for it, 1800 research publications in just 2 years after 1928 announcement. So many laboratories starting putting Raman scattering apparatus here. Now you go to any institute, any IIT or any ICER, most of them will have definitely a laboratory named as Raman scattering laboratory. Chemistry people are using it most. Okay.
Thank you, sir.
Sir, my curiosity, sir, is time traveling possible, sir? Time traveling. It's not related to C.V. Raman's effect, but is time traveling possible?
Well, I'm not the expert in that area, but I will say no. My short answer is no. And don't ask me why no. Because I'm not an expert in that area. But what you call time travel, this is also important. Okay? Is it that if you want to know what had happened 100 years ago, and if you see with your eyes today, on 28th of February 2026, what happened 100 years ago, if you call that time travel, would you call it time travel? Will you call it time travel? If I tell you that I will show you an event which has occurred 100 years ago or 200 years ago, I will show you with your eyes, not film, not photo, live. You will be seeing live event. Will it be okay? Will it be time travel?
Sir, according to me, it's yes.
It is good. Yes, yes. Tonight you go in some open place, look at the sky. Huh? Those stars, that flickering, that light, the star is emitting light. Many of the stars which are visible in your night sky emitted that light hundreds of years ago, thousands of years ago. But then most of them are not visible if you go in thousands. But hundreds are very bright. So you can see live events which had occurred hundreds of years ago. That is time travel? Yes, it is possible.
Okay. Yeah.
Thank you,
No.
sir.
Thank you, sir, for answering. Definitely, you will have a lot of questions, but we have time restriction. And sir, can I tell your mail ID so that people can? Yeah, it is there. Sir's mail ID is hcvarma, ed@gmail.com. If you are having any doubts, you can mail to sir. And okay, sir. Okay, sir.
Okay, so since all right, since that mail ID is being given, so I have to tell more about that. Number one, you write a mail to me, and in general, I don't answer mails. In general, but a small fractions of yes, light, some small fraction of light is scattered by the molecules. Some small fraction of the mails I answer also. So take a chance. Do take a chance. And not only that, if I don't reply, repeat the mail after 2 days. Okay? If I don't reply within 2 days, I will not reply after that. Surely I will not reply. So if you are keen to get your answer from me, you write a mail, possibly I will reply. And if I don't reply for 2 consecutive days, write it again. Still I don't reply, write it again. Keep doing that till I reply. Huh? Yeah. So in the first go, if the probability is 10%, in 2 goes, 3 goes, okay, keep doing that. We have several programs for you. Our group, which we call NANI, National Anveshika Network of India. We have a group of some 28 centers where different teachers are involved in Anveshika program, and there are other programs also in which I am there. So there is a program called National Anveshika Experimental Skill Test. Can you repeat?
No, sir.
Yes, National Anveshika Experimental Skill Test, right, NAST. Now this program is specifically designed for students of class 9th to 12th. Class 8 students should also listen it. Next year you will be eligible. Or class 7 student, 2 years down the line you will be eligible. So in this, this is a national competition kind of, and online we get registrations from students, class 9 to 12, and also college students also. And then about 25,000-30,000 students apply every year, and we gave them varieties of physics problems, not numerical problems. Not numerical problems. The test is on experimental skills. So in the first round, we will show you some small videos. Small means in seconds, not in minutes. 5-second video or 10 seconds video. We will show you online that you can see on your mobile phone or from wherever you have registered to this competition. And then we will ask physics questions on that small video. Yesterday we had display of that. And from that answers, your answers that you will be pressing different buttons in your mobile phone or the computer that you are using, the system will select some 800-900 students for the next round. The next round you have to perform the experiment at your home, because these 1,000 students or 800 students will be scattered in different parts of the country, right? So, and the same experiment has to be performed by them. So each one will be doing the experiment at his or her own residence. So we design the experiments in such a way that it can be done in your house, and you have to use only the material which are available in your house already, like your containers, your bottles, your many things that you have. So those things which are available and which can be obtained from grocery shop or stationery shop, but not from a scientific store. Okay, so this is our second round. So, and 3 such experiments we will give you to do, one after the other, and for each experiment we will give 1 week of time. and taking help from others is allowed, not forbidden. Okay? Oh, we encourage the participants to bring their friends. First is you will have to, that is a necessity. You will have to take help from your parents, because otherwise they will not allow to pick that box. You said, "Oh, such a nice transparent box is there, and some pulse or some rice grains are put there. I need this for my experiment. I have to put water in it and send light and then see how it deflected and all that." So to get that, you have to take help from your right. Then when you are doing the experiments, you alone may not be able to, you only have 2 hands. So you may need 2 more hands to perform the experiments. So your siblings and other members on your family. So we encourage anyone, even if your physics teacher is willing to help you, we don't have any problem. But then after doing the experiments and writing the whole report in a PDF format, which is sent to us, then our team analyzes all those answers. And since it is a very, very subjective thing, each student will do it differently. Each student, there's no standard design. So the student has to design. So this is not to compete with each other. This is to give you the competence of thinking, designing, coming up with something new. In school experiments, all the operators are given to you, and you know the books are there or the instructions are there, add this point to that point and connect this point to that point and so on. But here you have to think how to design your own apparatus. So that skill is to be developed. So it's not testing alone, it's also developing those skills which will make you a good physicist, a good, of course this is a physics test, so in that direction, those 40 students are called there. And then we design experiments from them, all the time new experiments. Every year we design new experiments. And on those experiments, they do experiments. And then our team evaluates how you have performed the experiments. But our evaluators of those experiments, they are given a very strict instruction. What? Huh? No partiality. Absolutely. Here you will be becoming national winners, and you will be earning a lot of scholarship and prizes and awards from there. So no partiality, of course. The instruction to those evaluators are, during the entire period of experiment, which goes in 3 hours, 4 hours type, they have to watch. Each evaluator is assigned that you have to watch this particular experiment. These are the 5 people who are doing this experiment. And all these 5 you have to continuously watch, continuously. And if you find that the student is not able to do such certain thing, because either the person is not experienced or is not exposed to, there's some measuring apparatus, some vernier calipers, etc., that the person doesn't know how to use, then this evaluator has to sit with the student, teach them there, then and there, help the student to complete the experiment. The strict instruction is, no student can go without performing all these experiments successfully. And that is the responsibility of these invigilators, come evaluators and these people. All right? So everyone who is called there will perform 3 new experiments under our supervision. And from that we will find national winners, etc., etc. So each stage you get to learn something. If you have appeared for the first part, you see a very new kinds of questions. Very new kinds of questions. You will never see these kind of questions, 5-second video and then there is physics question. In any of the Olympiad test or this, that, any varieties of competitions which are being organized, So you get to know you will get a new experience. If you are not selected for the next one, good. You gotten some experience, fine. If you are selected for the second part, then you are designing your own experiments at the home. And our experience is that when the parents come at our place with the children for that final rounds, then they all said that this boy is mad. Or this girl, my girl. One Calcutta mother said that I revealed my daughter only during this experiment. I didn't know that my daughter has these skills and she can think this way. Okay? So it's a very nice experience. If you are not selected for the final round, okay, you are not coming to my home. But you have learned that designing new experiments, writing reports, making graphs, doing that error analysis, all on your own, right? So every stage you have learned something and then you have gone. And there's no registration fees at any place, 0 registration fees. So this year's 2026 NEST is the registration will open on April 1 and will remain open for about 30 plus 20, 50 days, around 50 days. So if you connect to us using this site, or you connect to Jyoti ma'am or any of the people who are here in science in this VITM, they will coordinate, they will help you to get registered and like that. Your school teachers, if the school teachers are here, you can talk to school teachers, they can help you in registering. So April 1 to May 20 is the window when you can enter this competition. Okay? Thank you.
Yeah. Thank you, sir. Sir, during this National Science Week, we have done a lot of programs, but in that we did one drawing competition on the theme contest Women in Science Catalyzing Vikshit Bharat, and we had the year-long program of annual science quiz, Bangalore district level annual science quiz. The winners are there. Now I would request Professor S.C. Verma sir and Director VITM to come over the dais and distribute the prizes to the winners. And I request the winners to come fast and receive the prizes. First I will announce the result of drawing contest. And in the drawing contest held on 22nd February, the special prize goes to Arush R, 7th Standard, National Public School, Yashwantpur. And another special prize goes to Nisreyas MR from MVJ International School, Marathali, Bengaluru. Please be ready. Yeah, another special prize goes to Shanati Kulkarni, 8th Standard from Sri Ayappa Education Center, Madrahalli, Bengaluru. Please. Yeah. What is your name? Yeah. What is your name?
She's third prize. This boy didn't come.
Okay, then third prize you give her. No. Yeah. What is his name? You tell me. Yeah. Okay, third prize goes to Tanmay HR, Sri Ayappa Education Center. And second prize goes to Divyansi Mandal from MBJ International School, Marathali, Bengaluru. And first prize goes to Yuvan Singh, 7th Standard, National Public School, Yashwantpur. Then this first prize. in Bangalore district level annual science quiz. Third prize goes to students of Aikya School, JP Nagar, Adip Sudarshan and Nandita Rajesh. If students are busy, sometimes if the exam, if parents have come, you please collect on behalf of them. Second prize goes to students of National Public School, Rajaji Nagar, Vedant Satish Patil, 10th standard, and Samit Chakrabarti. On behalf of National National Park. But she told National Public School. Madam told. Yeah, first prize goes to students from Royal Concord International School, Alisha Lal and Medhansh Vishal. In the semi-final rounds, students from Auden Public School, Aviram Sastri DP and Rushikesh MS. If any parents have come, please come and collect on behalf of them. And students from the Brigade School, Mahadevapura, Arum Rawat and Omkar Mahesh. Then students from Freedom International School, they have come. Then students from JSS Public School, Adarsh Krishna. Student from JSS Public School, Adarsh Krishna J and Niharika C. Then students from Siddharshan Vidya Mandir, Jayanagar, Tanish Gubba and Mupashani Rohan Kumar. And students from Delhi Public School, Bangalore South, Aryaman Bhattacharya and R. Sriram. If anybody have left or anybody has come, please come forward.
Said to go on stage and also.
As a token of, thank you, sir, for distributing the prizes. And as a token of our love and appreciation, I request our director, Sri K. Saju Bhaskaran, to hand over a moment to Professor S.C. Verma and felicitate. Yeah. Now it request our director to felicitate Sri Amit Kumar Bajpayee, Chief Coordinator of Personal Relation from Shiksha Chopin, IIT Kanpur. Sir is instrumental in organizing the teachers training program yesterday. And yeah. So really these 2 days, yesterday and today, it was like a celebration of physics, and we gained a lot of knowledge on properties of light, and today definitely all the students have got benefited, and Sir has told about the exam. Definitely many people will enroll for that. And on behalf of Vishweshwara Industrial and Technological Museum and National Council of Science Museums, it's my privilege to propose vote of thanks. In spite of Sir's busy schedule, actually we are trying to get Sir since last 2 years, and after that we got, so we are fortunate enough to have him today, and thanks for accepting our invitation. Professor H.C. Verma, renowned physicist and author, and spending his time here along with us and delivering a wonderful lecture today. And we do not know how it spent almost more than 1 hour, 1 hour 20 minutes. So, people are very curiously listening to you, sir. It was so interactive, and yeah, yeah, that's great, sir. And our sincere thanks to Mr. Amit Kumar Bajpayee, Chief Coordinator of Personal Relation, Shiksha Chopin, IIT Kanpur, who has come over here from Kanpur for conducting yesterday's teachers training program with helping sir, and being present today for this program. Thank you very much, sir. And our thanks to Professor VSS Sastry, sir. He is throughout the yesterday and today. Sir is here. Thanks to VSS Sastry, sir. And thanks to the press and media people, those have, especially Doordarshan, they have come here for covering this event today. And our sincere thanks to all the students, those who have turned up today for this program. Students from National Public School, Yashwantpur, a big thanks to them. And students from Sri KK Education Center, students from Dean's Academy, Whitefield and Gunjur, both the branches, and students from Shishya BEML Public School. A big thanks to the management, teachers, those have come here and supporting us in all the programs, and in future also it is expected that you participate all these programs. We will bring new programs for you all. And thanks to my colleagues in the museum. So without their support, it is very difficult to organize the programs. And a big thanks to my colleagues in the museum, and thanks to Anandal. Have a nice time. Please visit the museum after this program. We have 7 galleries. Explore your different galleries, visit the museum, and we have different shows also. Of course, you have to pay the charge for the show if you want to go for the shows. And we have arranged a light refreshment for you. Please have the refreshment. And thank you all. Thank you. You are signing out. Thank you. ಪೇರೆಂಟ್ಸ್ ನಂಬರ್ ಇರಬೇಕು ಮೋಸ್ಟ್.
ಪೇರೆಂಟ್ಸ್
ಪೇರೆಂಟ್ಸ್ ನಂಬರ್ ಬಂದಿಲ್ಲ ಅಂತ. ಓಕೆ.
this one since the children didn't come.
ಓಕೆ. ಎರಡು ಆರು ಆಗಿದೆ. ಒಂದು ಸಿದ್ಧಾರ್ಥ ಮಾಡಬೇಕು ಮಾಡಬೇಕಾ? ಓಕೆ ಮಾಡ್ಕೊಂಡು ಬರೋಣ. ಮಾಡ್ಕೊಂಡು ಡಾಕ್ಟರ್ ಸಾಹೇಬ್ ಸೈನ್ ಮಾಡಿ. ಔಷಧ ಕೊಡಿ ಸರ್ಟಿಫಿಕೇಟ್ ಒಂದು ಚೇಂಜ್ ಮಾಡಬೇಕು. ಏನು ಔಷಧ ಒಂದು ಕೊಡಿ. ಸಿದ್ಧಾರ್ಥ ಸರ್ಟಿಫಿಕೇಟ್ ಮಾಡೋಣ ಮಾಡಪ್ಪ. ಪ್ರಿಂಟ್ ಅಂತ ಹೇಳಿ ಹೆಣ್ಣು ಕೇಳಬೇಕಾ ಸರ್? ಹಾಂ
Sir,
ಹೇಮರಾಜ್